Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of George Mason University and Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, find other episodes, comment on this podcast, and find links and other information related to today's conversation. Our email address is mail@econtalk.org. We'd love to hear from you. My guest today is Eric Raymond, the author of The Cathedral and the Bazaar, and a key figure in the evolution and understanding of the open source movement. Eric, welcome to EconTalk.
Glad to be here.
I want to talk about the ideas in your book, The Cathedral and the Bazaar, which is one of the most stimulating and informative books I've read in a long time. To get us started, let's cover some background for our non-technical listeners. You call yourself a hacker, but you use that word to mean something different from the normal mainstream media use of the term. What is a hacker?
The media use of the term is corrupt and wrong. You'd have a lot of reporters nowadays wanting you to think that a hacker is a person who commits computer crimes and breaks security on machines. This is not the correct sense of the word. Properly, a hacker is a member of a culture or a connected group of cultures that has existed since about 1960. And hackers built programs and give away software. And in particular, one of the things that we did is build the Internet and the World Wide Web. And nowadays, we work on Linux and a lot of related open source development. The reason the term hacker got hijacked is because crackers, people who break security, generally aren't very skilled. They know that the people in the real hacker culture are more skilled, and therefore they sort of appropriated that term for themselves in order to sound more capable than they actually are usually.
And you're persisting in using the word correctly.
Yeah, that's right, because there isn't a better word for the members of this culture.
It reminds me of the appropriation of the word liberal, which in the 19th century meant a belief in individual freedom and limited government, and has since come to mean something close to the opposite, but we've lost that one. So I hope hacker can stay with the meaning that you like, because I do like that. Now, talk about what open source software is. I think a lot of people have heard of it. They've heard of Linux. But what is open source software, and how important is it in our lives?
Open source software is a folk practice that evolved over a period of decades in this culture that I've been alluding to, of building software in a fundamentally different way than was accepted outside that culture. Outside the culture of hackers, as I've described it, there has been for a long time a belief that you had to develop software in small, secretive teams, and not show the source code to anybody, and not showing the source code to anybody was frequently tied to a desire to collect secrecy rent on a product that you shipped. Within this culture, on the other hand, we developed a tradition of working collaboratively, sharing sources with each other, and subjecting all of the software we did to basically the most peer review that we could get. And eventually what happened is that the Linux development, the development of a Linux operating system, which was powered by this method, started to attract a lot of notice and make some waves that were economically significant. And then a few years after that, I came along and figured out why it was successful. We had an unconscious folk practice, and I was the person who made it conscious, who articulated the ideas about openness and transparency of process and peer review that had been sort of inchoately floating around in the culture for a long time before that. And the effect of actually articulating this, of actually having a theory of open source, was that we could reflect on what we were doing and improve our process.
And what are some of the programs and software that are out there that use open source that are important? So there's Linux. What else is there that people might have heard of?
To somebody who is not tremendously computer savvy, probably the best known open source program at this point is Firefox, the open source browser that has been making great strides in market share because, well, it's better.
And for those who are technically savvy, what are some of the important open source projects?
I like to say at this point that our flagship product is Linux, because that's the operating system which has increasingly drawn a lot of other open source projects onto itself. as a common platform. Then another really important project is Apache, the Apache web server.
And how important is that? What kind of market share do you think it's close to?
Well, Apache hovers somewhere running, depending on whose market share figures you believe, it's running somewhere between 60 and 70% of the websites in the world. And it tends to be in particularly high use in websites that have to be 100% reliable and on sites where performance is an issue. So the more demanding the web application is, the more likely it is it's being hosted on Apache.
So let's talk about, as one more background issue, the logistics of open source for those of us who don't participate. Although some of us may have a little flavor of it in Wikipedia, for those of us who aren't technical, where with Wikipedia, anybody can play with it who wants to, but those of us who don't know about the details of Linux, in the back of my mind is this idea that Linus Torvalds, who's the what you want to call him, the proprietor of Linux, the manager of Linux, the
only begetter, the originator.
The originator of Linux is something of a gatekeeper. And in the back, again, sort of the vague idea that I have is that, well, people make suggested changes in the code, which is totally public and available, and he either gives them a check mark, in which case they become part of the new Linux as it goes forward, or he doesn't. Is it that simple, or is there more to it?
Broadly speaking, that's correct. The Linux project has developed a somewhat more complicated structure than that. Linus has lieutenants whose judgment he trusts, and a lot of patches are passed by his lieutenants. But what you're describing is broadly typical of open source projects. You have one person who's the project founder, or his successor, or a small group of core developers, and what they will basically be doing is they'll be maintaining the architectural integrity of the project, and their job also is to filter ideas and patches coming in from outside. The typical project organization is you have, as I said, one person or a small group of core committers that is constant, that stays with the project for a long time, and then you'll have outside that a much larger population of casual contributors who are doing reviews and contributing patches. Maybe a casual contributor will contribute one or two things and then go away and never be heard from again, but that's okay. If the stability is provided by the core group.
Now, if I make a change to Linux that is turned down, I'm free to use my version of Linux, correct or not correct?
That's correct.
So I just can't distribute that, and it doesn't become the version of Linux that goes forward.
Well, in fact, you could, if you wanted to, fork the entire Linux kernel and attempt to distribute your own Linux kernel in competition with Linux. It's very unlikely that a lot of people would pay attention to you. Forks like that don't tend to be very successful. But there's no technical or legal bar to your doing that, and that's very important. The freedom to fork is very important. It's what keeps project leaders on their toes and keeps them from becoming autocrats.
And in the book, you give some examples of projects that have forked that, although it's rare and it can be controversial among the community of users, it does happen.
It causes huge controversy when there's a fork.
Why is that? If let's say you do fork and there's this new version, if I don't like it, I won't use it. What's the issue? Why does it cause controversy?
Because
other than the thought that it might be inefficient, right? That you got multiple versions.
Well, in fact, that is one reason that we have a fairly strong taboo against hostile forks, because it's inefficient. It divides the community's resources. You get people working on one fork and not working on the other. Fixes don't get propagated across the divide. It's just ugly all around. We don't like it. But more fundamentally, there's a sort of customary law, almost like common law property rights in the community. I analyzed this in my second paper, Homesteading the Noosphere.
Right.
People are, in effect, farming the software they develop for returns and reputation. And the reputation translates into various different kinds of gains. You might get a better job, or you might look good to a peer group whose approval you value, things like that.
Glory.
What's that?
You get glory.
That's right. And so people are farming their software patches for reputation gains, and therefore if somebody makes off with your patch, it's considered a bad thing. In fact, the worst thing you can do, the ultimate taboo, is to file somebody's name off a project. That would be utterly horrible.
Let's talk about that, because I didn't understand that as a non-hacker. How does a hacker get glory? So if I debug Linux, or if I add a patch, and you should probably tell us what a patch is. I assume it means it fixes something, but I'm not 100% sure. Or I add a feature. How do people know that it was me? And I want to add that you point out in the book that good hackers use their own names. They don't use goofy, cutesy, cliched, boring, tired, clever names. They use their actual legal names. So how does that happen? How do I know if I'm using Linux right now, or if I'm if I'm a hacker, how do I know who were the creative people who were involved in different parts of it? Do you assign it?
There's a couple different mechanisms for that. If you're new to a project and you're just reading the source, there is often a credits file. And there will sometimes be credits in individual files in the project as well. And after you've been hanging around the open source world for a while, you notice who the steady people are. You notice who the regular contributors are, the people who do good work. And it's like, if there's a sort of power law distribution, there's a few people who are everywhere.
But here's the question. If I make a small change versus a massive change, is that recognized, and how?
If you just send a patch, you might get credited in the contribute log, in the commit log of the project, but you're not likely to show up in the credits. In that situation, people who send in small patches usually aren't motivated by the hope of glory or anything. Usually, they have a problem with the software that they want to solve, and it's more efficient for them to ship that patch to the maintainers and have it be incorporated in the main line of the software than it is for them to maintain their entire own branch.
Yeah, no, that's very cool. Now let's turn to the incentives now. One of the obvious advantages that Linux has over other systems, and these in general open source has, is you phrase it, you're quoting someone, with enough eyeballs, all bugs are shallow.
That's me, actually.
Okay. Oh, you put it in quotes, if I remember. So it's a nice phrase, and it's
that was my statement of a principle that I thought that I had detected. I thought that I had detected that Linus Torvalds was operating as though this principle were true, even though he hadn't consciously articulated it.
And hasn't written about it, or.
That goes back to what I was saying about the folk practice that had been developing for decades since the early 1960s. We gradually, over that period of time, and I've been involved in this process since the mid-1970s, so I had 20 years of observation to go on when I wrote my papers. 20 years of observation of a growing awareness, though not articulated, that decentralized peer review basically trumped everything else as a quality assurance method. Everything else. And the open source movement became conscious at the point where people realized with the top of their brains that that was true. And when I wrote about given a sufficiently large number of eyeballs, all bugs are shallow, I was both saying something. I was articulating it in a new way, but I wasn't really saying anything that longtime members of this culture didn't already know unconsciously.
Sure.
Oh, that was one reason that the open source movement caught fire so quickly.
Because it was effective.
That's right.
Now, as an outsider, the implication is that all software is buggy, and those of us outside tend to think, well, every once in a while you get a problem and you fix it. But as these systems get more complex, bugs tend to spread, and it's a huge issue of how to weed them out, I suppose. That's
right. And what the regime we're in now is that the size of the average code base has reached a level where nothing short of total process transparency and openness of source actually works.
Give me an example of what you mean by big.
The Linux kernel is, last I checked, approximately 6 million lines of code, might be up to 9 million by now.
Slightly longer than the programs I wrote using PL1 in 1973, I think.
Back when you were writing, 100 or 200 line programs, in PL1 in whenever that was,
they were
a couple decades.
It was 1973, and it was a really cool program. It could make change. Like, say you gave somebody $5, it would calculate how much, if the price was $3.73, how much it would give back. That was computer science.
At that scale, there are verification methods like formal proofs of correctness, structured walkthroughs, and so forth. At that scale, there are lots of other verification methods for software that work. The problem is, once you get past a certain scale, those methods run out of steam, and distributed peer review doesn't. Someday, distributed peer review will run out of steam. We'll need something like strong artificial intelligence just to debug our programs. I don't actually know what we'll do when that day comes. There's no silver bullet. No solution is permanent.
Sure.
It's just that in the regime we're in now, it seems to be the case that open source is really the only thing that we'll do.
And you're referencing a long idea an old idea in social science and applying it to this world where it hadn't been applied before, which is sometimes called the wisdom of crowds, the market, the fact that there's knowledge. It's a very Hayekian idea. Right. That prices contain knowledge that no individual participant in the market can possibly have. Right.
It's a Hayekian idea. My debt to Hayek is very explicit. I also like to draw a connection with the way that the scientific peer review process is supposed to work. There again, if you have some fundamental new insight about, quantum field theory or the sex life of salamanders or whatever, you can talk about it all you like, but it's not accepted as part of the body of knowledge that other scientists will work from until not only your results, but your experimental designs have been subjected to review by your peers. And what was a no-no was that in software engineering, for various wacky reasons, we developed a practice of hiding the experimental designs, hiding the source code.
In the name of keeping the profit stream going.
Right.
So let's talk about that. But first, I want to talk about your metaphor, which I love, the Cathedral and the Bazaar. That's the title of the book. It's the title of one of the essays in the book. Describe that distinction, and because I want to play with it for a little bit, and then we'll get to the incentives.
It works on a couple of levels. One is that I was referencing a book by Fred Brooks called The Mythical Man Month, that some of your readers may be familiar with. There's one level on which my essays are a reply to the Mythical Man Month, which Fred Brooks wrote around in the mid-1970s, and which dominated the thinking of people who did large-scale software engineering for a long time. And this was a book that observed that the fundamental problem with software is it's tremendously complex, and you have a problem of complexity control, and the things that you need to do to control the complexity of software include keeping your teams really small and keeping your objectives very tightly defined and managing the entire process with exacting control. You notice that I've described all the things the Linux community doesn't actually do.
Correct.
Another feature of the Brooksian method was long release times, during which you spent most of the time within your release intervals obsessing about squeezing out the last bug. Again, this is something the Linux community doesn't do. We operate on very short release cycles.
Sometimes every day, you pointed
out. That's right. And Brooks analogized programmers to cathedral builders, and for the style of development he was advocating, that was a very good metaphor. It's very vertical. It's very centralized. It has implications of hierarchy and tradition and so forth.
And grandeur and perfection.
That's
elegance.
Right, and aspiring towards heavenly perfection. Yeah. When I observed about the Linux community, what I observed is they were violating all these rules in an effort to get the maximum feedback from the most possible number of eyeballs. And the result is a very messy, contingent, horizontal sort of process. And in my title metaphor, I wanted to capture that sort of opposition to the cathedral, and it seemed to me the Bazaar was the best possible metaphor.
And that's Bazaar for those of you listening at home.
That's right. I actually almost called the paper the Cathedral and the Agora, after the ancient Greek term for a public meeting place.
Yeah. Well,
but I thought that would be less accessible as a metaphor.
Yeah, and I like the idea that the Bazaar is flat. It's and it's very wide potentially. It's not narrow and tall. It's not a spire.
And you go to a bazaar, and it sounds like everybody's babbling at each other in a really unstructured way, and it takes a while before you notice that there's an implicate order. There's a self-organization from the bottom up that structures the whole process in very subtle ways. Again, this is a Hayekian sort of idea.
So here's the puzzle, and I think it's obviously it applies to many economic phenomena that this is an example of it. On the surface, you would think that closed source software would be elegant because someone's in charge of the process.
Right.
There's an architect. You'd think open source would give you this weird Rube Goldbergian contraption with stuff tacked on here and there without that central architect. And yet the way I understand the critique of much closed source software, which I think I maybe first heard from Neil Stephenson, the opposite is the case. The closed source software is unstable. It's ugly. It's tacked on. It's full of patches that are not holistic and clear. And the large complex open source projects are cleaner and more stable. Is that true? And why?
Often that's the case, and there are a couple of different reasons for it. One is you talked about architects, but in fact, all good software needs to have an architect or a small group of cooperating architects at the center. That's something that's constant across both closed and open source.
It's a great point, because it's the same argument about central planning. You hear sometimes in a market system, you say, well, under a central planning system, you have planning, but under a market system, it's random and chaotic. No, there's planning in a market system. It's just done by individuals rather than top-down centrally.
And the difference isn't in the presence or absence of architects. It's in the social machine around them and how it reinforces and checks what they do.
So describe that.
In closed source, the social machine is essentially dysfunctional. One way that it's dysfunctional, there's this notion in closed source that you can do review internally to a company. You take a second group of engineers and say, okay, look at what this group of engineers over here on the other side of the company did, and tell us whether it's good or not. The problem with this is the whole process is subverted by the fact that ultimately both groups of engineers are reporting to the same people.
Right.
So there's all kinds of subtle pressure to minimize problems. And the problems that get minimized are the ones that the customer eventually ends up tripping over.
Which is a bit surprising, because you'd think they'd want to make the customer happy. Right? That would be the idea.
Well, are you familiar with the Discordian snafu principle?
No.
Okay. This is great. This is an important law of social dynamics, which I learned long before I wrote my papers. The snafu principle goes like this. It's associated with something that's either an elaborate joke posing as a religion or a religion posing as an elaborate joke called Discordianism, but I won't go into that right now.
Okay.
Anyway, the snafu principle says that in any hierarchical authoritarian organization, inferiors will be more consistently rewarded for telling superiors what they want to hear than they will be rewarded for telling the truth.
Okay.
The result is that there is a progressive disconnect between the people at the bottom of these organizations who can do but not decide, and the people at the top who can decide but not do. And the deciders are getting perpetually worse information because the information they get is distorted by the power incentives in the system.
We've recently been talking about this implicitly on EconTalk with Arnold Kling, who makes a distinction between the geeks in the suits at Fannie Mae and Freddie Mac, the people who understand the real risks of the system and what's going on in the ground versus the people who are the people at the top. But I want to challenge. Go ahead.
I want to explain the reason I brought in the snafu principle is because it explains why peer review within the same organization doesn't work.
I hear you.
And conversely, why peer review in the open source community does work, because you see, in the open source community, we're not all reporting to the same bosses.
Yeah, I hear that.
We don't have bosses at all.
Right, but there's a trade-off there, and what fascinated me, one of the things that your book made me think about is the role of the profit motive in a corporate culture. Most good corporations, of course, they want to make as much money as possible, but strangely enough, that is never their motto. Their mission statement is never, we want to make a lot of money, or we want to have as large a revenue with as small a cost as possible. Rather, they have beautiful, inspiring things about how their product interacts with consumers' lives, et cetera. And of course, in the background, they do have to make that profit. So there's this, not tension, because the way you make profit is by making the consumer happy, but you are constantly having to focus the players in the corporation on the consumer, because the bottom line part is also so relentless. One of the advantages, it would seem to me, that open source has, and we'll talk about the disadvantages in a little bit, but one of the advantages it has is almost by definition, it's only focused on the consumer, whether that's the hacker himself or the pleasure that people get from making people happy because the software works better. This tension between the bottom line and the consumer, which should be aligned through competition, it's just evidently hard for people's brains to keep that connection in the back of their mind at all times. So I think, go ahead.
Here's the most important economic fact about open source, which is directly connected to what you just said. Open source is not a way to make money. It's an enabler for other activities that make money.
Okay, and so explain what those are and how that works.
For example, let's say that you are a vendor and you want to sell a piece of hardware. My canonical example is a networking card, an Ethernet card. Okay, let's examine two different cases here. In one case, you go the traditional closed source route and you ship a binary driver with that card. And people who buy that card have to price in the risk that you're going to go out of business and that driver won't be maintained, or that there are bugs in the driver that they can't fix. They're relying on you to fix them, and you're probably understaffed and perpetually trying to cut costs and delaying fixes correspondingly. On the other hand, let's say that you sell your Ethernet card with a disk which includes not only the driver but the source code and a pointer to a website where there's a collaborative community maintaining those drivers. Now, the customer is in a completely different world. They have confidence because the driver is under open source licensing that the death of your company won't kill the hardware they're relying on. Therefore, its value to them is increased. Furthermore, even short of the death of your company, the value of that hardware is increased because they can rationally expect that the open source software will have a lower defect rate than the closed source software would, for a number of reasons. One is transparency and peer review, and another is simply having more people working on the problem. You can assemble much larger communities of open source volunteers for a task like that than most companies can afford to hire.
So let's now get to the what I like to think of as the nub of the matter, which is a fascinating issue we've talked about here a few different times, with different guests. Lots of different things motivate people, obviously. Money is one of those things. Glory is another. The thrill of being part of something large and extraordinary. Artistic satisfaction, craftsmanship, we might call that. So those things all matter. But for most of our economy, and I heard Walter Williams say this the first time. First time I heard this was from Walter Williams. He says, if you want to get steak to New York City and potatoes, if you want to get people in Nebraska and Idaho to get up early in the morning and work really, really hard at a very unpleasant, sometimes unpleasant job, and to get food into the metropolis of Manhattan and New York, we could choose to rely on their good nature, or we could choose to motivate them via profit. And motivating,
we know which method will work.
Right, the profit thing works extraordinarily well, and the love thing, occasionally it works. The image I like to use is, if you want your brother to take you to the airport, or do you want to rely on a taxi? And I love my brother. He happens to be extremely reliable, so I'm pretty sure he'd be there on time. But a lot of us, I think, have brothers who would say, I think I'm going to go with the taxi.
There's a piece of engineering jargon I want to introduce at this point.
Yeah, go ahead.
It's a useful thing for economists and business analysts and everybody to know about. One of the deadliest things an engineer can say about a proposed solution is it doesn't scale.
Correct.
That is, it works at small problem sizes, but there are nonlinearities in it that make it stop working when you scale up the problem. What in engineering jargon, what Walter Williams was pointing out was that love doesn't scale.
Correct.
As a solution to economic problems.
So then we come to the question of why is it that so many people see Linux or Wikipedia as a labor of love, not motivated by money, right? Obviously, there's some people who can make a living at it through various selling the glory by enhancing their reputation and then getting a job elsewhere. You've mentioned that, alluded to it, and you talk about it in the book. But of course, many people are just doing it for the fun of it, or the thrill of it, or the excitement of it. So why does it work so well?
Okay, because there is a very special set of circumstances operating here. There's a very particular set of conditions under which love scales effectively. And the open source movement fulfills it. I don't know of anything else that does quite so neatly. Even Wikipedia doesn't. And I'll get into that in a moment. Remind me if I don't get there.
Okay.
The kinds of intangible benefits that we've been talking about, artistic satisfaction, wanting to look good to your peers, so forth, they scale up to producing good, productive work when you have the following particular conditions. 1, the capital goods required to do the work are cheap. 2, the limiting factor on the work is human creativity and attention. 3, the work is intrinsically rewarding. And 4, there is an objective metric for success. If any one of those conditions fails, the machine don't work so well. And Wikipedia is an interesting case because they fulfill all of the conditions except 4.
Which is, again?
That's right.
Which one?
The only one they fail is there's no objective metric for success.
Right.
When you're writing software, there are generally fairly clear metrics for whether you succeeded or not. The program runs or it crashes. At a level subtler than that, you can do things like regression testing, unit tests, and so forth. Generally, you know if it's working. Okay, but when you write an encyclopedia entry, there is no metric for truth. There is no ground truth other than the judgment of other human beings who might be just as eccentric and crazed as you are.
And even a failure to have it be corrected doesn't mean it's a good entry. The fact that it's factually accurate is not sufficient to make it a good entry.
Crowdsourcing tends to work well in situations where there is an objective metric of success that everybody in the hive mind can agree on without too much effort. Without that condition, you get thrashing.
Right.
The other conditions are also important. If it might be the case that you had a kind of work where there was an objective metric of success, the work was intrinsically rewarding. I forgot what I specified as condition number 2. But if condition number 1 fails, which is that the capital goods are too expensive, it's not going to happen because the capital goods required to do the work are so expensive that nobody can afford to do it for free or as a hobby, except a very few rich and lucky people. Now, I chose that failure mode for a reason because that's the situation the hacker culture used to be in. That's why it used to be that there were only a few of us because way back when computers were really expensive. I date from that period.
Sure. Yeah.
So those are the 4 conditions, and I'm sure I could list them all in order if I had to again.
Okay. But, our listeners will grab them. They can rewind if they need to.
Yes. So that's the answer, or at least I think it's the answer. You need that particular set of conditions for the whole swarm attack on production to work.
Now, there's lots of things in daily life that have a swarminess to them. A lot of volunteer organizations, religious institutions, charities of various kinds rely on voluntary labor to a large extent, or voluntary labor paired with paid labor to achieve their ends, and they work varying degrees of success. I think the puzzle-solving aspect of hacking gives it a great advantage, but as you point out, it's only one of the things that matters. Now,
there's actually a 5th factor now that I think about it.
Yeah,
it's one that I was taken for granted. Zero cross communications.
Yeah. Cheap ways to communicate. Very cheap.
Yeah.
Because otherwise, somebody's fix is too hard to find out about and too costly.
Right. And again, I can look back in the history of the hacker culture over the time that I've been involved with it, and I can look back and I can see the really stifling effects of high communications costs, which we didn't notice at the time.
Right. And why were they so high? Because internet was the only source for that kind of communication?
Well, I mean, it's hard to remember now, but there was a time before the internet.
Yeah, right. Well, that was obviously a different time.
For the general public, the internet became a reality in the early 1990s. I'd say around 93, 94 was the big internet explosion. For the hacker culture, we were using the internet fairly effectively 15 years before that. But only some of us had access to it because it was associated with large universities,
military
contractors, and so forth and so on. And I remember back in the 1980s feeling like I was on the outside looking in because the bright lights and the fast communication and the big interesting development projects were going on the real ARPANET, and here I was stuck out here in UUCP land with my pokey serial communications. It was kind of nasty.
Yeah, the world has changed a great deal.
It's changed a lot.
Now, when you talk about things not scaling, I mean, one of the thoughts that I used to have, which I think is wrong based on what I learned from your book, but I want you to share it with everyone else, is, this is a nice thing. It's great that some people have this hobby of tinkering with Linux or Apache or whatever it is, or creating GIMP, which is, a free alternative, a zero-price alternative to Photoshop or these other programs. That's lovely that people tinker with it, but it doesn't scale in another dimension, which is everybody can't have it as their hobby. They've got to have a real job somewhere else. And what I found fascinating about one of the things I found fascinating about your book was the observation of how little software is actually sold, what a small amount of hacking is actually done directly as what we might call piecework. Right. So talk about that and why that matters.
Well, it matters because most software expertise isn't deployed for sale on the merchant market. Mostly it's deployed because people want to solve business problems and they need some kind of bespoke solution. A really good example of this is the huge number of people who are employed developing and maintaining schemata for databases. Okay?
Internally.
Internally to companies, and people who build report generators for corporate databases and so forth, and people who build COBOL number crunching programs for banks. Most of the programming effort in the world happens at these places. There's a prevalent belief that the typical programmer is working at some place like Microsoft or Oracle producing software for the merchant market, but that belief's false. And in one of my early papers, and often in my talks, I challenge the audience to go perform an experiment to verify this, which is to go look at the position advertisements in your local paper. Well, as it was back then. Now you do it on the web. Go look at a jobs board and look at the programming jobs and just do an audit. Count tick marks. How many of these jobs are software for use as a capital good inside some corporation versus software for a packaged product? And you'll find the overwhelming majority of jobs are for internal use of software as a capital good. And that's why it turns out not to matter that you can't make money doing open source. Because most software isn't produced for money anyway. It's produced to solve a business problem. It's an enabler for something else.
But you do need, one of the things you don't talk about much, which you allude to it a few times, is the genesis of a program, of an open source project. So someone's got to, let me say it a different way. It's one thing.
Wait, before we get there, let me point out one exception.
Yeah, go ahead.
I mean, it's an exception that sort of proves the rule. The one exception is computer games. Computer games really do have to be sold on the merchant market, but it's noticeable that they're very short lifetime products, and very few people are actually employed producing them. I simply want to note that I'm aware of exceptions to the paradigm. Anyway, you were saying somebody has to start.
Hang on. I want to come back to that.
Yeah.
When you say there are a small number of people working on computer games,
yeah.
What's a small number? You're talking about the design side, right? You're talking about the people who are creating the next World of Warcraft or whatever is going out, whatever is the hottest game.
I've never had been asked to give a numeric estimate before, but from what I know about the industry, my guess is that there probably are not more than 3,000 or 4,000 full-time computer games programmers in the United States.
Well, we got to fix that. I mean, come on. This is a national crisis.
And again, the economic reasons for this are fairly clear. There isn't enough money in that industry to support huge legions and scads of programmers. The profit margins are very tight because the products have a short lifetime and competition is ruthless.
Do they have a short lifetime because people get bored with them? I don't know anything about that market.
I don't know that much about it either. That's probably a major reason, but there may be others I don't know about.
Okay, so let's go back to where we were, the origin. What creates once a project gets going, once there's the gatekeeper, the founder, a project that's useful is going to attract people who are working on these getting the multiple eyeballs going. Mm-hmm. But what about have you thought about? Imagine a world where could you imagine a world where all software was open source? And how would it
have to do with the question you're asking?
Well, I'm wondering, in that world, would the genesis of projects be the same in an open source world as a closed source world? Which is to say, GIMP, which I picked because I'm interested in photography, GIMP comes along because Photoshop's really expensive. Somebody says, Photoshop's expensive, and one of the reasons that open source is attractive is it's quite cheap.
No, I think your generative theory is wrong.
My what?
GIMP is popular because open source is expensive, but GIMP didn't happen because open source is expensive. GIMP happened because Spencer Kimball and somebody else whose name I don't remember thought it would be really cool to write a graphics program.
Okay.
Open source projects typically start because somebody has an itch and they feel like scratching it. And they start writing on a piece of code, and if they're good and if they're lucky, both things have to happen. Other people look at that code and go, wow, there's a cool idea there, and I could make it cooler with a patch.
Right, and I think this is a tension you allude to in your really interesting cultural analysis of hackers, and there's a range of motivations for people. Some people, as you say, I think most of them, are in this game because it's fun and it's useful. Others are in it for ideological reasons that they're against the corporate property system. They want to bring it down. And what you're suggesting is that group isn't the dominant creator of new projects.
It isn't. No. You do get some people in that group creating software occasionally explicitly to break a monopoly, and that's okay with the rest of us because the rest of us dislike monopolies on general principle. We may not have any problem with big corporations, but we don't like monopolies. And actually I should talk about the reason for that a little bit.
Go ahead.
We don't like monopolies because we're engineers and we've learned to be deeply suspicious of systems with a single point of failure.
Interesting point, yeah.
That's a very basic reason for not liking monopolies. Also, monopolies tend to get obsessive about secrecy and control and lots of other kinds of behavior that we don't like. And the reason we don't like it is sometimes it's partly ideological, but mostly it's you're stopping me from getting my work done. You're stopping me from solving my problem. Secrecy is a barrier. It's the enemy of quality. Well, and this is that's a deeply powerful emotional motivation for a lot of us.
Okay, I agree with all that, and let me challenge it and get your response.
Yeah.
Let's think about three types of organizations: an unmanaged one, an open source project.
Well, we have management.
I know.
Yeah.
Well, sorry, a bottom. Well, I don't know what you want to call it. A crowdsourced project.
Yeah.
A Microsoft and an Apple. Now, there's different returns, monetary returns, there are different glory returns, and there's different secrecy environments in all three of those systems. The impression you get from the outside is that Apple seems to be very good at attracting deeply creative people.
Mm-hmm.
But it is a highly secrecy.
And then they burn them out really fast.
Okay, I don't know anything about that. Microsoft, I think of as, again, this is the stereotype, as a stodgier, less creative place. That
they burn their people out really fast too, but for different reasons.
And it's very secrecy oriented.
Yeah.
But Apple's been very successful recently, not so much before, but recently in generating extraordinarily successful products in that secrecy environment. So they must be doing something else to get those creative engineers and design people who don't like to work in that environment. To get them to do that. And I don't know what internal mechanisms they're using for motivation besides money, but money is one of the things.
I have an idea about some of them.
Yeah, well, money is...
There is a certain mystique associated with Apple.
Correct.
Some people want to be next to that, especially if they've been Apple users their entire lives.
Yep.
Another thing is that there is one thing that Apple does extremely well that the open source hacker community is, well, we used to really suck at it, but we're getting better, but we're still not real great.
What's
that? And that is industrial design, making things pretty.
Yeah, no, that's right.
Apple is really good at that, and people who are attracted to making things pretty are going to like the idea of going to work somewhere where that is a really significant focus.
And I would add that most of the examples we've talked about, and correct me if I'm wrong, most of the examples we've talked about that are the screaming successes of open source are products that are consumed by hackers. To take an example,
Firefox is a big exception.
Firefox is the exception. And Firefox has a really beautiful and pleasant to use user interface. A lot of the products we're talking about, the user interface doesn't get the attention because the hackers who use it don't need to have it be easy to use. They know how to use it. But those of us on the outside find that a little bit intimidating.
Right. There's another factor as well. Remember when I said that the swarm approach tends to work best when you have an objective metric of what is good?
Right.
That objective metric isn't really, it's harder to apply in user interface design than anything else.
That's a good point. Very interesting.
The swarm mind approach tends to work less well there than it does in other areas of software. The open source culture is gradually realizing this, and we are gradually evolving a practice in which we essentially appoint UI dictators within each project.
UI meaning user interface.
Right, user interface dictators within each project, and they get their way. Because the rest of us are gradually figuring out that trying to do that kind of thing by committee just doesn't work.
And it's just...
It's better to have a flawed individual vision than try and do it by committee.
And not everybody has an aesthetic sense. I think, and in fact, one might argue that there's a negative correlation between hacking ability and aesthetic sense on average.
No, absolutely wrong.
Okay.
Absolutely wrong.
Why?
Because...
I said one might argue. I didn't say it would be correct.
No, okay.
but
actually, I'm glad you brought this up.
That would be the stereotype, right? Right, you're really good at making...
This up because it's a good thing to shoot down, actually.
Go ahead, go for it.
So, programming only looks like a mechanical, logic-saturated activity at its lowest levels. That is, you always have to be able to do logic. You have to be able to follow long terms of chains of deduction and reason effectively about things and so forth. And you have to know a lot of mechanics about declaring variables and declaring functions and how this module feeds into that module and so forth. The thing is, though, that as you get better at programming, a lot of that stuff becomes quasi-automatic. It becomes routinized. You get to the point where if you're a really good programmer, you learn entire programming languages in like days, and you do it routinely to work on new projects where the toolkit is not what you're used to.
Like a musician learning a new reed instrument. If you can play the saxophone, you can learn the clarinet, right?
Right. And it's a great deal like music in that at the lower levels, there's a lot of painful practice and detail and mastery of technique that you have to have. It requires a great deal of mental discipline and application to get right, and a lot of people never make it through that phase. Once though you reach a certain level, you find that more and more of what distinguishes the top performers from the mediocre ones is aesthetic sense. Good taste, because aesthetic sense correlates in some mysterious but very definite ways with the qualities of software that make for good engineering, that make for stability, performance, robustness over time, and so forth. And so at the very highest levels, and it's relevant here that the hacking community tends to attract extremely talented programmers, people who are right up towards the high end of the bell curve. At the highest levels, aesthetics is all important.
Right, but important. But I'm going to challenge you because I think it's a certain kind of aesthetics. Mm-hmm. If you think about Leftbrain, Rightbrain, which I know people debate whether it's real or not, but hackers tend to be left brain, and you're suggesting there's a right brain aspect to hacking, which I'm sure is true. I understand the idea of, even from the outside, of elegant code or an elegant solution or an elegant workaround or patch. But what I'm drawn to, the reason I raised the stereotype initially of a negative correlation is I think back to the early days when the first Apple computers came out, and the screens were, they weren't terribly attractive, but they were relative to the IBM PCs of their day, and the Macs when they came out, they weren't Macs then, but the Apples that came out, the classic, they had different fonts and they had a nice screen. Mm-hmm. And there was a certain part of the computer user community, maybe not the hackers, but who disdained that. They wanted their green typeface on that black background or whatever it was at the time, and they wanted it as cold and command liney as possible. But that maybe is an unfair.
No, it's not unfair. In fact, I originally come from one of the cultures that was disdainful of the Mac way back when. I'm an old Unix hand, and we were the ultimate command line guys. And the reason for that, part of the reason for that, was we didn't think it was an appropriate use of computers, and there was an argument that we were right at the time to put on a lot of visual glitz because we had better things to do with that computing power.
Sure, I hear you.
Nowadays, that isn't true.
Right, because it's cheaper.
Clock cycles on a computer in memory are so much cheaper that it isn't really a good argument anymore that you shouldn't be spending your resources on making it pretty, because we have so many resources to throw at the problem.
Yeah, and
go
ahead.
There's still an argument of that kind with respect to programming time, because programming time is a more limited resource.
You bet.
But it's not that much more difficult anymore to make things pretty. There are some circumstances under which you should stick with a command line. Certain kinds of data analysis tools, for example, you can't get the right kind of flexibility in a GUI. I've been involved with projects like that. But that reflexive disdain for the pretty interface has pretty much subsided at this point. That's very 20 years ago, and I'm speaking from deep experience here because I made that entire journey personally myself.
Well, here. Let's turn in the last part of our conversation to public policy. I'm going to open up two Pandora's boxes. You can take one or the other or both and run with them.
Okay.
Two big issues in the use of information and the internet right now are property rights and this issue of net neutrality. Do you have any strong thoughts on what direction we ought to be going in those areas?
Well, let's take net neutrality first because it's easiest. I understand one of the reasons you wanted to talk with me is because you saw a posting that I wrote on this subject.
Yeah, and we'll put a link up to it as well. So remind our listeners what the issue is of net neutrality and what you think ought to be done about it.
The issue in net neutrality is that the telephone companies want to double dip. They want to both charge subscribers, their individual residential and business subscribers, for access to content sites, places like Google or YouTube or whatever. They also want to charge the content suppliers differentially for providing fast access to the people on the other end. So they want to be able to say, Google, you're using a huge percentage of network traffic. We're going to surcharge you because you eat up so much bandwidth.
So is that a good idea?
What?
Is that a good idea?
That's a horrible idea.
Why?
Because the fertility of the net, the thing that makes it wonderful is friction-free communication. And now you're saying that these that these carriers want to be able to put arbitrary friction barriers between you and the people you might want to talk to.
So if they do that, won't they struggle against other competitors?
Well, yeah. I mean, I think ultimately that approach is doomed because the underlying economics doesn't support per-bit metering. And this is something I've actually written about before, although I don't think you've read any of that stuff.
No.
The underlying economics doesn't support per-bit metering because the real cost in networks isn't the cables, it isn't the bandwidth, it's in the intersection points, the routers and the people needed to maintain them. Mm-hmm. And that doesn't actually scale with usage.
Okay.
So also, there's this problem that if you try to meter bandwidth, you quickly find that your metering mechanisms are more expensive than the increase in margin from the metering.
Right.
Lots of people have tripped over that problem. And that's why flat rate peering and flat rate internet connections continue to be so economically strong. And I don't think that's going to change in the future. So I actually don't think that's sustainable.
Isn't the claim that by allowing the possibility for this kind of differential pricing, we'll get better investment in the capital and the infrastructure?
Right. And they're so lying.
Why?
They're so full of crap. I mean, they've sung that song before. They've said, "Oh, give us this market rigging and these regulatory privileges and the ability to raise rates, and we'll build fiber out to everybody, and our broadband access problem will be solved." And it's never happened. Never happened. The telcos always use that rent to make the walls around their monopoly higher, to buy legislators, to bribe regulators, in effect, and to make the situation worse and worse and worse. Somehow, we're always a few years from good broadband, and the telcos are always coming back around saying, let us squeeze more rent out of people, and you'll finally get it. It never happens.
But why should government have any role in it whatsoever? Why shouldn't the solution?
I don't think it should, actually.
So what is the issue then?
The fact that this is considered a public policy issue is basically a historical convention.
Yeah.
What was that?
I find it strange. What's different? Why we don't tell car companies, bad example these days, but car companies or other companies, well, you have to charge this, that, or the other, and you'd like to charge more, but sorry, we won't let you, and that's just not what government.
The reason this market is so distorted is because between about 1880 and 1920, there was a guy named Theodore Weil. He was the first honcho over at AT&T, what became the Bell system. And he made a sort of devil's bargain with the U.S. government at the time. He said, you give us control of the last mile, and we'll give you universal service. And the result was the Bell system essentially appropriated the last mile, and they've been squatting on that monopoly ever since as though they had some actual property right to it, as though it wasn't first, last, and entirely a creature of government regulatory fiat. And they want to have that both ways, and it's ridiculous.
So what do you think is the ideal solution?
The ideal solution is to take as much radio spectrum and fiber out of regulation as possible and let the market operate.
And what do you think? Speculate on what might evolve. What might emerge?
What might evolve? What I think would emerge is heavy use of what's called mesh networking, decentralized mesh networking, where you have cheap, intelligent routing nodes that are so inexpensive that people buy them like they buy pencils and scatter them all over the place. And these mesh nodes come up and they'll connect to whatever wireless spectrum or pieces of fiber are available. And then they'll find out what nodes are near them, and there are ways to write algorithms that will cause the entire network to optimize itself bottom up and be self-healing. Okay? The internet architecture already took a long step towards this. That's why packet routing and decentralized routing is important. With that kind of system, we could have huge amounts of bandwidth everywhere with no central control choke points anywhere. And we're heading in that direction because the last mile is gradually being end run by wireless technology. Sure. And one example of this is the phone that I'm speaking with you over. I'm using an Android phone, the Google G1. The Google G1, the Google phone, the G1, has a browser on it. I mean, it is a fully capable internet and web capable appliance that I can carry around, and I have access to it anywhere that I'm on the cell phone network. Why is this interesting? Well, because it undercuts the last mile monopoly that the wireline telephone companies are squatting on. If I can look at a browser on my Google phone anywhere that I'm near a cell tower, the fact that the wireline telephone company owns the fiber to my house becomes a lot less important, doesn't it?
Although it's still hard to watch a good full-screen movie on it. So that's one of the places it's...
It's true, but that's an engineering problem.
Yeah, we'll
There's
fix
no
that.
fundamental reason that shouldn't work.
We'll fix that.
We'll fix that.
There's no doubt about it.
And we'll fix that in fairly short order. So I think unregulated wireless spectrum is the solvent that can allow the market to break up this long-standing telco monopoly.
Yeah, I think you're right.
And this is a case I have tried to make to the other side in the net neutrality wars, which is the coalition of activists that are pushing to solve the problem with more government regulation.
What do they argue for?
What they argue is that the government should basically enact various kinds of mandates on what the telephone companies can and cannot do. And they completely miss the fact that kind of regulation is what got us into this hole in the first place. The telephone companies, on the other hand, love these guys. They think they're the best enemies they could possibly have. Because every net neutrality activist saying that we need to regulate our way out of this problem is reaffirming the entire system that locks the telephone companies into positions of power. Yeah. That says, all we have to do to keep our profit margins up is buy another handful of regulators.
Yeah. Yeah, it's going to be interesting to see how that plays out. I think you're right, though. I think technology is going to, I hope, make it a moot point.
So that's the net neutrality thing. And there was a long period when I was spending a lot of time on a mailing list trying to educate net neutrality activists, and they couldn't hear me. For them, it was all about the politics.
Sure.
It was all about minor tweaks to the regulatory system.
Just get it right this time, yeah.
Yeah. And the other thing you want to talk about was intellectual property?
Yeah, let's put that to the side. I want to ask you something else instead, if that's okay, because we're almost out of time. I found myself getting a little bit nostalgic when you talked about the early 90s when the net first came into non-hackers' consciousness. I remember people telling me that the internet, this is probably, 93 or 94, that the internet was a good place to do research. And I thought, this is ridiculous. This is just, I don't need to learn it. This is some weird little thing that people are interested in. And of course, it's changed our lives in literally unimaginable ways. If you'd been standing in 1994 and said, how is the internet going to be practical 14 years from now, or 15 years from now, you really couldn't have imagined the wild scope which we now use the internet for various things.
I'll make a partial exception to that.
Okay.
The culture I was part of did imagine it. It's what we were aiming at.
Okay, well then that comes to my question, which is...
Even we didn't anticipate all of the second-order effects, though.
But here's my question then for the next 15 years. I want you to speculate on what you could imagine, and of course you'll be at least partially wrong, but speculate on what the next 15 years might look like, because I think there's always a tendency to say, well, we've kind of figured out what people can use the internet for, and that's that. What do you think creative, imaginative, talented hackers are going to create in the coming years that might be almost as transformative as the internet has become?
I was thinking about that question as you asked it, and two things come to the top of my mind. One is more and more mechanisms for enabling markets that are effectively friction-free. eBay and things like it are a long step in that direction. But we need lots of different eBays. We need federations of eBays, and we need eBays competing with each other so that, for example, no monopoly can get a lock on what the terms of sale for particular devices are. Right now, there are some things you can't sell on eBay, and that's bad. So we need lots more eBays. We need lots more places where people can do market transactions at infinitesimal or zero cost. And the second thing that I think may become really important is prediction markets. You know about those?
I do. My colleague Robin Hanson is a pioneer in that.
Robin Hanson, old friend of mine, actually.
And Robin, we've had him on talking about him, and there's a lot. So talk about what's going to happen there that you think is important.
The thing about prediction markets is that they have some ability to harness the kinds of crowdsourcing and swarm effects that we've been talking about for addressing problems that are much more general than how do you make a piece of software work. And as communication costs go further towards zero, I suspect that's going to become more important, especially if we come up with ways of appropriately compensating people for participating in prediction markets.
Well, we're currently we're taping this on January the 8th, 2009, and I'm thinking we're about I'd say a month away from passing a very large stimulus bill. I wish that the members of Congress were compensated based on, say, some aggregate economic measures that could be objectively valued rather than their motives and their desire to be seen as helpful.
Yes.
Since I am a skeptic on the likelihood that stimulus will work, I wonder if they would produce something different if their salaries and more
tied to changes in GDP.
Yeah, or unemployment. I don't know. But the part of the challenge of that, of course, is implementation. There, you've got a monopoly that isn't going to change the rules of the game on us. They're going to stick with the rules they've got, which are pretty valuable for them. But I think the opportunity of using prediction markets and other types of knowledge aggregators is an important future possibility.
And one thing you can count on is that hackers as a group are going to be on the forefront of all efforts to undercut monopolies, including government monopolies.
Yeah, it'll be interesting to see what happens. My guest today has been Eric Raymond, Hacker Supreme and author of The Cathedral and the Bazaar. Eric, thanks for being part of EconTalk.
You're very welcome.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.